Welcome students. Today we are going to start matrices of NCERT book exercise 3.1. Let us do some difficult question, all type of questions. Some other questions taken from examples and other sources. Let us begin. Now exercise 3.1. These questions we have question number 1. In question number 1 we have given a matrix these questions first we need the order of the matrix. In the first part, order of matrix, it is we know that here first row, second row and third row, these are the 3 rows and 4 column. This is our row number 1, row number 2, row number 3 and column 1, column 2, column 3 and column 4. So these are the order would be, its order first written number row, there are 3 rows and 4 columns, so its order is 3 by 4. Now in second part, the number of elements, how many elements are there? Number of elements, if you multiply 3 into 4, it will be 12, it is 12. Okay, so therefore the number of elements, also known as entry, number of element 4 into 3, 12. And in third part we have, in third part write the elements of A13. So A13, if I write in the generalized format, we need in the generalized format we have first row, first column element A12, A13, A14, second row first column element, second row second column, second row third column, second row is fourth column, and third row first column, third row second column, third row third column, and this is the third row and fourth column. So this is the matrix. We need the number of elements. If you compare the corresponding elements, then we have A13 first row this is the first row third column element, corresponding to this will be 19, corresponding to this 19, and second row first column, this second row and first column, it will be 35. Now in third part, A33 third row, this is third row third column, this is third row third column, corresponding element is -5, and second row fourth column, will be this one, second row fourth column, corresponding entry is 12, and the second row third column we have, second row third column element is this one, corresponding to this is 5 by 2. So this is our question number 1's answer. Now we go in question number 2. In question number 2, if a matrix has 24 elements, total number of elements are 24. So here like this, total number of elements are 24. So what are the possible orders it can have? So what are the possible orders? Then we can have the possible orders. How many matrices we can have? The possible order. So possible order can be the multiples of, if you multiply 24 has the multiples 1, 2, 4, 6, 12. These are the multiples. These are the multiples of 24. So we can make the product. First one is 124. The possible order is 124 and 24 cross 1. 2 cross 12, 12 cross the product should be 24 because there are total number of element 24, so we should have the product of the order should be 24. 12 into 2, and next one 4 into 6, and 6 and 4, and next one we did all one. Yes, so these are the possible order of a matrix. So number possible orders are, total numbers is 6 is the total number. So 6 matrices can be formed if there are 24 entries we have. Now what if it has 13 elements? Second part of this one, first part is this one, second part of this question is, if we have total entries are 13, so how many matrices we can make of this ones? We can make only because its factor is only 13 has a factor 1 in 13 only, so we can make 1 13th, another matrix 13 into 1. Only 2 matrices can be made if we have 13 elements. Now next questions, third one the same ones, and we do one part of the fourth questions. Now of this exercise, question number 4, construct a 2 cross 2 matrix. So we have to construct a 2 cross 2 matrix. The generalized element Aij element, we need to construct a 2 cross 2 matrix, and the given general term is given. If I go only the third part, question number 4, third part of the question number 4. So in this part, the general element is given Aij. The general element Aij, I plus 2j whole square, I plus 2j whole square divided by 2. This is our general element. We have to construct a 2 cross 2 matrix. First write all the entries of this matrix. The matrix would be, we have 2 row and 2 column. First row, first column element, first row second row element, and first row second column element, second row first column, and second row second column. These are the entries of this ones. So we need one by one. Let us do if I need A11, so in the general term here I and J both are going from 1 and 2 only. So I and J should be 1 or 2. So if I put I equal to 1 in these expressions, I equal to 1, J equal to 1, J equal to 1 also, it becomes 1 plus 2 into 1 whole square divided by 2. It becomes 1 plus 2, 3, 9 by 2. This is this entry. Now second one, say A12. This is the A12, I1 and J2. I1, J2, and now it becomes, if I place in the general terms, I1, J2, 2 multiplied 2, and it's a whole square divided by 2. It becomes 2 to 4, and 4 plus 1 is 5, square of 5, 25 divided by 2. So this is the second entry. Now third entry, we need A21, I2 and J is 1, I2, J is 1, therefore place in this general term. I is 2, J is 1, 2 into 1 whole square of this term divided by 2. Now finally it becomes 2, 2 plus 2 is 4, square of 4, square of 4 divided by 2, square of 4, 16, 16 by 2 will be 8, 16 by 2 will be the 8. Now the last term of this matrix, I2 and J2 both are 2, 2, and it becomes 2 plus 2 into 2 whole square divided by 2. Now 2 to 4, 4 plus 2 6, 6 square 36, 36 divided by 2, it would be 18. If I place all these values in this matrix, the terms or entry will be A11 is 9 by 2 and A12 25 by 2 and A21 second to first column 18, 8 not 18, this is 8, and A22 is 18. So this is the matrix we have constructed A2 cross 2 matrix, 2 rows and 2 columns. Now next questions, so I include only the difficult questions and different type of questions and some practice left for you. You have to practice your own so that you can make a very strong grip on the math. Now yes, now next one is question number, if I do same type of questions, fifth is same, we do next questions. Now question number 6. In question number 6, this is the question number 6, find the values x, y, z of the following matrix. So this is the equalizer of two matrix. This matrix, this question is based on the equalizer of two matrix. When do one part, third part of this question. So this is a quick learning and quick revisions if you do in this way. Now third part, x plus y plus z. X plus y plus z, x plus z, y plus z. We can write matrix in this bracket also, 9 5 7, 9 5 7. So this question based on the equalizer of two matrices. So in equalizer of two matrix, so if two matrices are equal, we have to check whether the order is the same, should be the same order. Should be the same order, then we can only check whether corresponding terms are equal or not. So here you know that this is the third row, three rows in first column matrix. This is also first row, second row, third row, and only one single column, so 3 by 1. So this is 3 by 1, 3 by 1. So if you equalize starting from the last one, yeah, we can go anyway. So now first one, first entries. Now x plus y plus z is equal to corresponding term is 9, and x plus z, here x plus z is 5, and the third term is y plus z. Your y plus z is 7. These are the three equations. If you solve this one, these three 1, so we will get the value of x, y, z. Yeah. So let us do, if you add x, y, z, first add second and third. If you add second plus third, to here x plus y plus 2z. So here x plus y plus 2z, x plus y plus 2z will be 5 plus 7 is 12. If you subtract equation number first from equation number 4, this is your fourth equation. Now subtract from fourth equation number first. If I subtract this one, left hand side is x plus y z, and your left hand side x plus y plus z. So here x plus y plus 2z, if you subtract this term x plus y plus z, x plus y plus z, it will become 12 minus Okay, this is 12 and this is 9. 12 minus 9. 12 minus 9. So from here, this cancelled, plus minus cancelled, 2z minus z is z. Now finally you get 12 minus 9 is 3. So z has the value 3. Now if you put the value of z in equation second and third, if I put the value of put z which is 3 in second, so I will get the value of x plus z has the value 3, x plus z is 5 from here. So x 5 minus 3, 5 minus 3 is 2, and if I put z in put z 3 in equation number third, so we will get y plus z which is 3 is equal to 7. From here y is equal to 4, 7 minus 3 will be 4. So therefore our answer becomes, to write the answer x and y and z. So these are the values, x is 2, y 4, x2, y4, and z has the values 3. So these are the answer. This is the answer of question number 6, part 3rd. Now question number 10 of exercise 3.1, and question number 10 of this part is the number of all possible matrices of order 3 cross 3 with the entries 0 and 1. So we have a matrix whose order is, the general term of this matrix Aij. So the order is 3 cross 3. But the entries of this matrix be only 0 or 1. So here 0 or 1 entries should be only these one. So how many types of matrix there would be? So if I write the general term of this matrix, which would be first row, first column, first row, second column, first row, third column, and this is second row, first column, second row, second column, second row, third column, and this is third row, first column, third row, second column, third row, third column. So this is our matrix which is 3 by 3. So the given condition is, so entries should be the only element of this matrix. These are the entries, okay? These are 3 into 3 is the 9. 9 is the entries, or also called elements. So here your elements entry will be only, okay, the corresponding entry, each entry should be 0 and 1. So we know that A11, each entry can be 0 or 1. Each will be, we can place, we can put A11 either 0 or 1. Similarly 1 to 0 or 1, so on. So each terms can have only two elements, that is 0 and 1. So we have the total number of element is 9. So these are the 9 elements. So we can put in these 9 elements. So each entry should be 0 or 1. So this will be 2 plus 2 plus 2, 2 plus 2 plus 2 plus 2 plus 2 plus and 2 plus. So total entries, how many these become 18. So therefore we have the 18 number of entries we should have. So here these are the 6 into 6 into 6, okay? 3 multiply 3. So total number of, if I place, total number of entries are entries are 9. So total number of entries are 9. So we replace 1 1 by 0 or 1, and each entry should be replaced by 1. So total number of entry is equal to A11. So because there is a combinations, okay, how many combination we can make? So we can make A11 is replaced by this can be filled by 0 or 1. These are the two integers, and A12 is filled by this A13. So in this way we can write this 9 times. Okay, this is first row. Also multiply 2 cross 2 second row entries and third row entries also. So it means that these elements can have either 0 and 1. It means that total number of entries in each total number of integers and each entries would be 2. Therefore the total number it becomes, if you simplify this one, so it comes out 2 raised to the power 9. So because we have in matrix, if you increase any entries, if you change, the matrix would change. So total number of matrix, total number of entries we can have 2 to the power 9. It comes out 512. So the part answer is this one. So possible matrices we can have 512. So 512 is a possible matrix, because if you change, if all the entries, suppose if I only changes only this A11, all should be the these values. If I place 0, starting with 0, so this become one matrix. If you replace the 0 by 1, start with 1, so this is another matrix. If all other entries are same, so in this way this becomes 2 matrix. So in this way, if you change any entries in 2 times, okay, either 0 or 1, to 2 matrix already done. So therefore the total number of matrices we have, there are total 9 entries. So 2 raised to the power 9. So 512 matrices would be made by these 2 entries, either 0 and 1. So next one's this is exercise number 1, and we would go operation on matrix, how the matrix is added, subtracted and multiplied. These are the algebraical operations under the matrix. Now this is the addition and subtraction of matrices. So for addition subtractions, so there is a need only it's possible only 2 matrices can be added and subtracted to each other if their order should be the same. This is the necessary condition. The order should be same. So only you can add and subtract the corresponding elements of these 2 matrices. Let us start one example. Suppose we have this is matrix A, corresponding element is 2, 3 and 5, and its element -7, 7 and 5, -6 and this one. This is the matrix A. Now second matrix B is, suppose it had the element 1, 4, -2, -3, 6 and 8. So this is another matrix. So you look at the order. First look at the order. It has 2 rows and 3 columns. 2 by 3 is the orders. It has also 2 rows and 3 columns. So same order. So we have the same orders. So we can add and subtract the corresponding element. So if I add, so if I need to find out the A plus B, okay, adding these 2 matrices. If you add these 2 matrices, we will get also a same order, that is 2 by 3 cross matrix. So first we have to add the corresponding element to 2 plus 1. Okay, A11, this is A11. If you add these 2 plus 1, corresponding elements should be added and subtracted. Here we are adding these 2 matrix, and here second entries of the first rows is 3 and this is 4. So 3 plus 4, 9, 9 plus 2, 22, 22 plus 1, 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 22, 22 and 5 this is minus. Okay, so 5 plus should be in bracket because there is a minus. 2 minus 6 and minus 6 and plus minus 3, and 7 plus 7 plus 6, this is corresponding entries, and 5 plus 8, this is 5 plus 8. If you simplify this one, this matrix becomes 2 plus 1 is 3, and 3 plus 4 is 7, 3 plus 4 is 7, and 5 plus 5 minus 2 is 3, and minus 6 plus minus 6 minus 3 will be minus 9, and 7 plus 6 is 13, and 8 plus 5 is also 13. So now look at the orders. Its order is again 2 by 3 matrix. So in this way we have added two matrices, and similarly we can subtract. Okay, we can make a difference these of two ones. We can go like a difference of these if I subtract matrix B from A, so 2 minus 1 becomes 1, 3 and minus 4, 3 minus 4 minus 1, 5 minus plus 2, it becomes 7, and minus 6 minus plus 6, it comes out minus 6 minus 3. So it has the value minus 6 plus 3 minus 3. Now 7 minus 6 become 1, 5 minus 8, 5 minus 8, it will be minus 3. Now just simplify this one. 1 minus 1, 7, and minus 6 plus 3 will be minus 3, 1, and 5 minus 8 is minus 3. So it has the entries. So in this way its order is again 2 cross 3. So this is the 2 cross 3 matrix. Now we move ahead. Now properties of matrix addition. First one is commutative law. If you have two matrix, so the order we can change here to A plus B are two matrix, should be the same order, only then we can add A plus B is equal to B plus A. So this is the commutative laws, and A plus B here. Let us suppose A in the general element, general format Ij, so its order is m cross n, and order B is also m cross n. So ijth element here bijth elements, order is m cross n. So it has both elements, both ordered are same, so we can add the corresponding elements. So now written in the general format, A plus B will be Aij m cross n plus Bij m cross n. Since here both have the same order, it has m cross n order, it has also m cross n, so we can add the corresponding element. So this is the ijth element, this is also ijth element. If you add the corresponding elements, it becomes Aij plus Bij. So this will be the new matrix whose order is the same as the component, it's a component m cross n. So here, yes, Aij and Bij. Okay, this is the ijth element of new matrix m cross n. So we know that we can interchange the order. Okay, in normal mathematics, two digits can be interchanged. 4 plus 3 is 7. We can write this 4 plus 3 also 3 plus 4. So 3 plus 4. So here if Aij and Bij is simple real numbers, so real numbers are commutative. Addition of real numbers are commutative. Therefore, we can write Aij plus Bij in this format, Bij plus Aij. So this will be the m cross n matrix. So Bij, if you split this one, so like when you have written these those two elements of two matrices in this format, we go in reverse order. Okay, from here to here. So therefore we can split this ones like this is splitted this one. So here if I split this one, so it becomes the ijth element of a new matrix m cross n plus this is the another ijth element, the ijth element of another matrix. So we have represented it Bij Mg. It is the matrix B and this is the matrix A. So in this way, okay, matrix addition is commutative. So we can add matrix addition like the normal real numbers. Addition of normal real numbers is commutative. Now second one is properties of associative. So now A plus B plus C, associative law. Yes, this is the under the associative law. So this is the case, like we have added this, we can also add this one. So here this is the ith element of order, let us suppose take m cross n. Second matrix is also its general element Bij, m cross n, order should be the same. And third matrix, matrix C, its general element Aij. We can add these matrices only when the order are the same. So these all have the same order. So now first check the left hand part of this one, A plus B plus C. If I put in the general format, Aij of order m cross n plus and B plus C. We have B plus C, A plus C. We have written A plus B like this format. So B plus C can be written in this way. The general element of B plus C will be Bij plus Cij. This is the ith element of this one. So now in earlier part, A plus B can be written in this format. Same way you can add these two. Okay, these are the two matrices, so both have the same order. Then we can add the corresponding terms. This is ijth element it has, and this is the ijth element. So ijth element can be added in ijth element if the order of the matrices are the same. So since the order are the same, so we can add corresponding part of this one. So we have added this corresponding part Aij plus should be, this term should be in bracket Bij plus Cij. So bracket is closed and order is m cross n. So order should be the same. So now we know that in general mathematics real numbers are associative. This is 3 plus 4 and plus 5 can be written as 3 plus 4 and 5. Okay, all have the same values. If you add 4 plus 3 7, 7 and 12. So this is real numbers. Some of the real numbers are associative because all these are the real numbers. They should be in associative. So in this way, so taken first and second term should be in same bracket and separated Cij. So now if I separate Cij from here, Aij plus Bij in one bracket, and I separated Cij, order m cross n. So so because Aij plus Bij can be written in the splitted format, so we can split this one. In the splitted format it will be, to write the general element, we have split this one because this is the addition of two real numbers. So we can split the addition of two matrices. So we have split this one. So Aij plus Aij plus Bij, order is m cross, and this is general elements, and Cij, this is Cij, order have the same one. So m cross 1. This should be written in matrix format A plus B and plus C. So in this way, so associative law, this is the right hand side part of this one. Now the third property of matrices, addition of matrices, additive identity. So additive identity means suppose if I goes additive identity of matrix additions, some of the real numbers. So if I add 3 plus 0, okay, 3 plus 0, if I get the same numbers, if I get the 3, then 0 will be your additive identity in the sum of the integers. So 0 will be additive identity. So in this way, in matrix, there would be also additive identity. Here the additive identity will be the 0, because in any matrix, suppose this is a matrix A whose order Aij, whose order m cross n, and another matrix 0 whose order is also, okay, it has a 0 entries, all entries of this matrix 0. So this is 0 matrix. If I add this 0 matrix, so A plus 0, okay, written in the general format Aij m cross n, general elements of the 0 matrix is m cross n. Now it becomes ijth element plus 0. We know if add any if you add 0 in the real numbers, it comes out the real number. So this is the Aij. So finally I get matrix A. So therefore 0 will be the additive identity here. Okay, 0 matrix, the 0 matrix or null matrix or void matrix. 0 matrix has 0 matrix. We can say 0 matrix can be said at additive identity. This is the additive identity. So 0 matrix will be your additive identity. Yes, next one, existence of, now fourth property of this one, existence of additive inverse. So existence of additive inverse, yes, we have each like in a sum of integer, like in the sum of the integers, so we have additive inverse. Okay, suppose what should be added in 4? What should be added in 4? We get the additive identity of integer, sum of the integer. Okay, we should have get 0. So if you add minus 4, additive inverse of 4 is minus 4. So we get 0. So similarly, if you add minus 5, minus what should be added in minus 5? We get 0. Okay, if you add negative of this one, you have to add negative of this one. So minus 5. Minus 5, it comes out minus 5 plus minus plus. So if you subtract this one, so okay. So minus 5 plus 5 will be 0. Okay, 0 is the additive inverse in the set of integers. So same way in matrix additions also we have this is the matrix A. Any matrix inverse of matrix A. Inverse of matrix A will be minus A. So this is matrix A, its inverse is minus. If you add these two matrix corresponding element, first this is the negative of the matrix of A. So if I add these two matrix A plus minus A, so I will get 0 matrix. This is our 0 matrix. So in this way, this is 0 is the additive identity and minus A is the additive inverse of A. So the negative of any matrix will be your additive inverse. So minus A can be called as additive inverse of A. Additive inverse of A